Wasn't this my this movie? It was, right? Really? Yeah. Wow. We got a lot of work.
Probably never more than 8. Well, I was on the quiz yesterday and we learned it. On my arm. This was on the quiz yesterday and we didn't even learn it. Oh, what was on the quiz? Is this an ionic compound or a covalent compound?
Yeah, but it was ionic.
I know it was, but still.
Alright, covalent compounds. So let's start by making a little flow chart with matter in the center.
Did it already make that?
Yes.
Just go back to that one or make a new one?
No. Don't do that. Do this one. And you should remember matter is broken up into 2 categories. One is pure substances. And then on the other side, we have some other category that we're still not going to get to yet. Pure substances are broken up into 2 categories. Elements. We spent a lot of time already on elements. That's the periodic table, right? The periodic table lists all the elements known to man. Well, I guess there could be 113 and 115 that aren't on that periodic table. And then the other category would be compounds. And this is what we started at the beginning of this chapter. And for the past 2 weeks, we've been talking about ionic compounds. Right, and this is what your quiz was all about here.
Jenny McCarty, please call 2503. Jenny McCarty, 2503.
Okay, so we're now done with ionic compounds. We'll actually come back to them for a day toward the end of this. And now we're going to do the other type. So here's the blank box that gets filled in now. This will be covalent compounds. And then there's sort of an in-between group that we'll get to when we talk about polar covalent, but they kind of fall into this. So this is where we're at today, covalent compounds. This is what we'll be talking about for the next week and a half. Then we'll have a quiz on this, and then after that we'll have a test on all compounds, ionic and covalent. All right, so let's see what are covalent compounds. I didn't leave myself much space. Compounds. So ionic compounds were what? They were compounds made up of a metal and a non-metal. So covalent compounds are made up of 2 non-metals. If we had 2 metals, that would just be an alloy, so I'm not going to bother talking about metals. So 2 non-metals make a covalent compound, and then in a covalent compound, atoms share 2 or 4 or 6, has to be an even number, electrons. So we're, I'll slow down for a second. So you'll remember that I told you in an ionic compound, one atom takes an electron from the other. And so that one's then negative, and the one that lost the electron is positive, and they're attracted to each other because they have opposite charges. In a covalent compound, neither one gains or loses electrons. They share them together, kind of like each one puts in an electron, and they share 2. And this, I should really write that separately, right? So let me make that a separate definition. So covalent bond, that's what this is called. Covalent bond is 2 shared, shared, gotta write slower. Shared electrons here. Everybody's got this, right?
Yep.
All right, so here's what happens. We have two nonmetals, they come together. Let's say they are oxygen and hydrogen. Okay, so we have hydrogen, it's got its electron. We've got oxygen. Oxygen should have 6 electrons, right? So if this was going to be ionic, then one would take the electrons away from the other. But this one's going to be covalent. And so what happens is, it's kind of like they both put their electrons into like the middle pot here. And they share them equally. And so now you have hydrogen, its electron, and oxygen's electron. And then the other ones that oxygen already had. And so these two shared electrons, this is the covalent bond. And if you think about it, every atom has a nucleus that has protons in it, which means every atom has a positive nucleus. And so both atoms, each nucleus is attracted to those shared electrons. And so that's why those electrons act like glue and they stick the atoms together. This isn't finished, by the way, because oxygen only has 7 valence electrons. So that's unstable, but just leave that for a moment. Okay, so that's your covalent bond. Last thing I need to define for you is molecule. So, what am I going to put here? Sorry, this is a little bit jumbled. I'm trying to get everything in the right order so it makes sense here. So, molecule is a group of atoms stuck together with covalent bonds. In other words, molecules are what covalent compounds are made of. So elements are just made of atoms. Ionic compounds are made up of a bunch of ions, and the ions are all stuck together because they're all attracted to each other. Covalent compounds are made up of a bunch of molecules. They're not stuck to each other. They're separate from each other. So a molecule would look like this. Let's do our oxygen again, right? And oxygen, if it's going to react with hydrogen, say you're burning hydrogen, it's going to react with 2 of them. So you're going to get this one here. It's going to share an electron. There's the little covalent bond. And then another hydrogen is going to attach to it, right? We all know the formula for water is H2O. So this whole piece here, the 2 hydrogens and the oxygen stuck together, this is a molecule. Now here's what's important. These ones are stuck to each other. There's very strong attraction between this hydrogen and this oxygen and these two. But the other molecules of water floating around have a very weak attraction for this water. So in covalent compounds, the molecules are kind of off by themselves and they don't have a very strong attraction. Whereas if you remember with ionic compounds, right, you got a positive ion, all the negative ions are attracted to it, right? And then all the positive ions are attracted to these ones. And all the ions are stacking up like this. In an ionic compound, all the ions are stuck together. In a covalent compound, you have these molecules where they float around by themselves. They don't really attract each other. So knowing this, knowing that the molecules aren't necessarily attracted to each other very much, what does that tell you about the properties of a covalent compound? These molecules don't have a very strong attraction for each other. So what should that tell you about the properties of a covalent compound? Kind of thinking right, but what is so what you're saying is right, but you're not saying the right words. The attraction between them is not strong, which means what? Huh? Which means they don't hold their shape. Which means what? They have low melting points, low boiling points. They're liquids and gases. That's what it means. It means the particles come apart easier. Remember, with ionic compounds, because all the ions are stuck together, they have very high melting points. They're almost always solids at room temperature. Yes, thank you. Good call. So yeah, because these aren't attracted to each other, covalent compounds tend to be liquids and gases. And so they tend to have low melting points and low boiling points. Remember, this is one of these things I keep trying to get across to you is you know, when liquids and gases, the particles are far apart. And so if something has a low melting point, a low boiling point, it's easy to push the particles, the ions or the molecules, whatever it is, apart. If it has a high boiling point, because it's hard to push them apart. So low melting and boiling points. And the other property, if we think about the ions, the electrons can move in between these ions very easily. Here, the electrons are stuck in there. They're covalent bonds. They're not moving away. So because the electrons are tied up inside their molecules, these things do not conduct electricity very well. So they don't conduct, supposed to be an N, don't conduct heat or electricity. Everything will conduct electricity if you have enough voltage, but these don't conduct it very well. Enough voltage. Anyway, so because the electrons are so tied up in their bonds, they don't move around easily, so they don't conduct electricity. All right, so that's it. So all you got to get out of this lesson is, well, I guess there's a lot in this lesson. The electrons are shared, so that means all the charges are neutral. Nothing has a charge. There's no ion. And because of that, we have separate molecules that aren't necessarily attracted to each other. So those are the key things. All right, so this is what we'll be doing for the next week or so, covalent compounds. I'm done talking.
And this will be all within second market period?
This will be, yeah, there should be a test on compounds that'll be second market period. That'll, if I